Hi everyone, welcome to the new session. In today's session, we are going to talk about one-one functions and many-one functions. Okay, so let's get started. Okay, so today our main point of focus, it will be on one-one function, one-one function, and many-one function. Okay, many one functions. Okay, so let's try to understand what does these both function or what do they mean. Okay, now we'll try to understand both these functions by visualizing the things. Okay, so let's say that here I have a function fx. Okay, uh, here I have a function fx, and this function is defined from set A to set B. Okay, and here I have a function gx, and this function gx, it is defined from A to B. Okay, now as we know that this is a mathematical representation of function. Okay, it means that uh, f is the given function and it is defined from set A to set B, and here A is our domain and B is referred to as codomain. Okay, so these are the basic things and I hope you are aware of these things. Okay, now this is my set A, okay, and this is my set B. Okay, and here the same set A, and here I have set B. Okay, so here I have set the elements in set A. Let's say that here I have A, B, C, D. Okay, and in set B I have elements 1, 2, 3, 4. Okay, now functions are classified as one function and many one functions. Okay, but before trying to figure out whether this function is a one function or many one function, first we have to understand that we have to check if the given relation to us is a function or not. Okay, if the given relation is a function, only then the given function can be classified as one or many one. Okay, so the first thing we have to check is that, is this function valid? Means that, is it really a function or it's a relation? Okay, so one and many one, they are types of function. Okay, so the first thing we need to make sure is that we have to check whether the given relation to us is a function or not. Okay, so once it is a function, then we can go for one and many one. Okay, now see here, one function. So one function, it follows one mapping. Okay, one mapping. What does it mean, one mapping? It means that each element in set A, okay, is related to one element in set B. Now see here, one. What does it mean? It means that each element is related to one element. Okay, each element is related to one element. Each element is related to one element, and this element is also related to one element. So this is one function because it follows one mapping. Okay, so it means that each element in set A in your domain, it must be related to one or single and unique element in set B, right? So here what I cannot do is that if I say that, okay, instead of this, if I have this, no, it's not 1 1. Why? Because 1 has 1 is the image of A, right? Because 1 is A is related to 1. So B cannot be related to 1, because if you relate B to 1, then it's not going to be 1 1. Then it's going to be many 1. Understand why? Because many will relate it to 1. So for any function to be 1 1 function, we have to make sure that each element in set A must be related to the single and unique element in set B. Okay, so here this is known as your 1 1 function. Okay, now go to many 1 function. Okay, so we are going to take the same elements A, B, C, D, and here in codomain I have 1 2 3 4. Okay, now many 1 functions, they follow many 1 mapping, right? So it follows many 1 mapping. Okay, what does it mean? It means that many elements in set A is related to one element in set B. See here what kind of scenario they are talking about. A is related to 1, B is also related to 1. See here, many 1. Okay, let's say here C is related to 2, D is related to 3. Okay, now this type of mapping is many 1, because here I have 2 elements that are related to one element in set B. So many are related to 1, even though they have a single and unique image, but I have 2 elements here that are related to one element. So overall, this function is going to be many 1 function. Okay, so as the name says, many 1, and here 1 1 means 1 on the left and 1 on the right. Okay, so that's what 1 1 functions and many 1 functions means. Okay, so I hope you understand it through the visual representation. Okay, so I call it visual representation. Okay, so this is our visual representation. Okay, now come to the mathematical understanding of 1 1 and many 1 function. Okay, so for mathematical understanding, or for mathematical definition, how would we define 1 1 and many 1 functions? Okay, now a given function fx, okay, I will write here, uh, a given function a given function a given function uh, a given function f, which is defined from A to B, is said to be 1 1, is said to be 1 1 if what? If fx of 1 is equal to fx of 2, then x1 is equal to x2 for all x1 x2 belongs to domain of function. Okay, or belongs to A. Domain of function here is A. Okay, what does it mean? Now see here, it says that a given function, for example, this is a given function, it is said to be 1 1 function if fx1 is equal to fx2, then x1 is equal to x2. Okay, now we'll try to understand this. Okay, if let's say that here I have element A and here B. Okay, so I'm taking these elements from domain. Okay, just trying to understand the things. Okay, and here I have 1 and 2. This is my set A and this is my codomain, which is B. Okay, now he's saying that this I would say it is x1 and this is x2. Okay, now if f of x1, okay, if f of x1 is equal to fx2, then what does it mean? If f of x1 is equal to x2, it means that here in image we are going to have just one element, right? See here, if f of x1, it is this is your f of x1 and this is your f of x2. Okay, if both are equal, then it means that it's going to be just one element, f of x1, right? Okay, now if you look here, then what will happen? Now you are saying it's going to be 1 1, but if f of x1 is equal to x2, then according to this scenario it should be many one, right? Because x1 and x2, they are related to the same element, right, here in set B. Now if it has to be 1 1, then what we have to do now, f of x1 is f of x1, it is equal to f of x2. Now when this scenario, it's possible when x1 is equal to x2. Okay, so when x1 is equal to x2, what does it mean? It means then here we just have one element, right? And here f of x1. Okay, so it doesn't mean that we have two elements here. When x1 and x2, they are going to be equal, it means we have just one element here, and we also have one element in set B, which is f of x1. Why? Because fx1 is equal to fx2. Okay, so we cannot write here f of x2 2. Why? Because both are equal. So instead of 2, it become 1, and here because x1 and x2 are equal, so here I can write just x1. Okay, so that's what it is saying. It's saying that if your fx1 is equal to fx2, you just use the mind and think that if f of, for example, here let's say that here I have 1 and 2. Okay, so this is the scenario. Okay, now f of x1 is equal to x2. Now a is pointed to, a is related to 1, b is related to 2. This is f of x1 and this is f of x2. Now if both are equal, it means then it's going to be 1, and they are going to point, they are going to point, both of these elements are going to point 1, right? But when this is going to be possible, when x1 and x2, they are equal to, if they are equal, then it means that here we just have one element, which is a, and here we have 1. So it will be your 1 to 1 mapping. Okay, I hope it made sense to you. It is very simple. F of x1 is going to be equal to f of x2 when here in domain x1 is equal to x2, right? Only then this thing is going to be possible. So that's what it says, that a given function f is said to be 1 1 if fx1 is equal to x2, then x1 must be equal to x2. Okay, if x1 is not equal to x2, then this relation is not going to be 1 1 function. Sorry, this function is not going to be 1 1 function. Okay, I hope this thing is clear to you. Okay, now come to the next side. Okay, so the mathematical understanding for this here, I would say that a given function which is g from a to b is said to be many one if there exists x1 x2 which belongs to A means domain, and uh, x1 is not equal to your x2, then f of x1 is equal to f of x2. Okay, now look at this, what it says. Now this is the same thing. Okay, this is the same thing. It says that here you have set A, here you have set B. Okay, this is your x1, this is your x2. Okay, so he says that x1 and x2, they are not equal. So if when they are not equal, it means that they represent, or these are not the same elements. Okay, so these are unique elements. Unique elements means they are not equal. Okay, so but here f of x1 is equal to x2. So f x1 is equal to x2 means that here it just represents one element. So now see here, fx1 is equal to fx2, then what would happen means that they are pointing the same image, right? So many one, right? Many one, that's what it says. Okay, many elements, they are representing, or they are pointing to the same output, right? Yes or no? Okay, so here in many one case, your fx1 is equal to f of x2, right? But x1 is not equal to x2. Now you will say that how is it possible? Okay, let's take an example of one function. Okay, let's say that the function here gx is x square. Okay, now this is my set A, this is my set B, right? So here when you put the values, different values of x, then you will try to come across one thing. Sorry, when you will try to put different values, then you will see one thing, and which is that for -2 and +2, you will get the same output 4. Now see here, f of x1, if you say this is x1, this is x2, then f of x1 is 4, and f of x2, it's also 4, but x1 is not equal to x2. So this is many one function. Okay, I hope this thing is clear to you. Okay, so this is what one and many one function says. Okay, now let's take some examples. Okay, let's take some examples, and we'll find some ways how to find out if the given function is one or many one. Now see here, if your function is not one, it means it has to be many one. Okay, so when you see any function, it has to be either one or many one. Okay, so if it is many one, then it's fine. If it is not many one, then it means it is one. Okay, now let's take example. Here I have f of x, which is x square, and here I have g of x, which is x cube. Okay, now we'll try to find out if these functions are one or many one. Now we know that the curve for x square is, if I want to draw the curve, it's going to be upward parabola, right? That passes through the origin. Okay, so it's going to be something like this. Okay, it's going to be something like this, and here I have cubic function, right? X cube, and the curve for cubic function, it's going to be something like this. Okay, something like this here. Okay, it's going to be something like this. Now, okay, so we need to check if the given function is, if which one is 1 1 and which one is a many one. Okay, now we can do one thing. When curves are given, things get easier. We can do a kind of horizontal line test. Okay, what does it mean, horizontal line test? We had spoken about vertical line test before, which helps us differentiating relations and functions. Okay, and what does that say? It says that if you draw a vertical line anywhere on the curve of the function, and if it cut curves more than once, okay, more than once, then it is a relation. But if the the vertical line cuts the curve just once or at most once, then it is a function. Okay, but to classify if it is 1 1 or many one, we have to do horizontal line test. Okay, so here I'm writing horizontal line test. Okay, horizontal line test. Okay, now see here, if I draw the horizontal line anywhere on this curve, okay, this is a horizontal line, then this horizontal line passes through the curve at 2 points, right? And if you draw horizontal line on this curve anywhere, then you can see it is just passing once. It is passing the curve once. Okay, here once, anywhere once. But here the horizontal line cuts the curve more than once. Okay, if horizontal line okay, if it cuts, if horizontal line cuts cuts more than once, cuts the curve of function, more than once, okay, more than once, then it means the function is many one. Okay, many one. And here, if horizontal line cuts the curve of function at most once, then what does it mean? It means the function is here 1 1. Okay, 1 1. Okay, this is very simple. Now see here, why is it so? Now if you look at this curve, when we drew this horizontal line to this curve, then you can see here the horizontal line cuts the curve here and here. Okay, let's say that this is my x1 and here this is x2. Okay, now if you look at f of x1 here, it represents this. Let's say this is y. So f of x1 is y, and here f of x2, again it's y. Means that we have same output for two inputs, which means that, see here, x1, x2, let's say this is your set A and here y. So this is going to be many one function, right? Many one function. But here, For different outputs, we have just one input. So that's why this is one function. So I hope this thing is clear to you. Okay, so you can implement this horizontal line test when you are given with the curve. Okay, now there is one more thing that we need to understand here is I can erase this. What is that? Sometimes it may happen that you are not given with the graphs, okay? And you are just given with the function in algebraic form, okay? Then how to know if the function given to you is one or many one, okay? So here this is for when the curve or graph is not given or unknown. Okay, then how can we find out if the given function is one or many one? Okay, now in that case we have to when the curves are not given or when the curves are unknown, we will see in the question like what could be the scenario when the curve is unknown. Means in algebraic expression you will get some variables the value of which is not known, so you don't know exactly what type of curve you will get. Okay, so in that case, you know, what options do we have? Okay, so in that case what we can do is, let's say that your fx is the given function. Okay, it's the given function in algebraic form. Okay, in algebraic form. Okay, so in that case, if we have to know if this function is one or many one, what we need to do is we need to find derivative of fx, which means we have to find f dash x, which is d by dx of fx. Okay, so we have to find the derivative of fx. Now if the derivative of x is less than 0, okay, or greater than 0, okay, then what? Then your fx is one function. And sometimes we also put here equal to 0, okay, but only at the discrete points. Okay, now I will try to explain this whole point. Now let's see that here, okay, here I'm drawing one graph. So this is the graph. Okay, this is the graph. Okay, and here I have second graph. Okay, and here it goes like this. Okay, and then here I have one more graph which goes like this. Now if you carefully look at these three, okay, and here I have one more graph. For more clarity we will take one more case. Okay, and this is okay, so I have four graphs here on the board. Okay, now this is the graph of what? This is the graph of increasing function. Okay, this is graph of increasing function, because if you look at this graph, it's increasing, right? This is the decreasing function graph. Decreasing function graph. Okay, again, this is also increasing function. Increasing function. Okay, and this is both in, see here, increasing, decreasing, again increasing. So this is both increasing and decreasing. Okay, now clearly this is not not 1 1. Why? Because when you draw a vertical line, then sorry, horizontal line, then it's going to cut the curve more than once. So therefore this is not 1 1, this is many 1. Okay, now come here, increasing functions. Okay, now if you look at these increasing functions here, you can see that these functions are increasing, but these functions are not passing through the origin, right? This is decreasing function again, it is not passing through the origin. But here we have increasing function graph and it passes through origin. Okay, now if you, let's say that this is the graph of or curve of function fx. Now if you take the derivative of this function fx, then it has to be less than equal to 0 or greater than equal to 0. Okay, the whole point is that if it is less than 0, of course it is 1 1 function. If it is greater than 0, then of course it's going to be 1 1 function. But it could be, in some cases, less than equal to, if it is less than equal to 0, then also it is a 1 1 function. Why? Because here, if derivative is equal to 0 at discrete points, now see here, this is a discrete point, it's fine. But when the derivative it's 0 in the interval, then it's not going to be your 1 1 function. What does that mean? If this is the case, okay, let's say that this is the case, this is your curve, okay, and here this is the graph. Now see here, now we have a problem. Okay, this is increasing function, because if you look at this graph, it's increasing, right? But this is not 1 1 function. Why? Because if you look here, if you look from here to here, the derivative of this function, it's going to be 0 in this interval. In this interval, it's going to be 0. So when derivative is going to be 0 in interval, then it is not 1 1. But if your derivative is 0 at discrete points, then we say that this function is 1 1 function. Okay, now come back to the discussion. This is just for your understanding purpose. Okay, now we said here that when the curve is unknown or when the graph is not given, then we can apply this rule. Okay, so we can apply this rule. Okay, now let's take a question. The question is find a for which the given function fx equal to x cubed plus ax squared plus 2x plus 9 is, find a for which fx is 1 1 function, 1 1 function. Okay, and where your a belongs to real number and your function is defined from R to R, from real number to real number. Now, we have to find the value of a for which this function is a 1, 1 function. Now, if this function is 1, 1 function, now we cannot draw the graph of this function. Why? Because a is unknown, right? We don't know the value of a. So we have to find the value of a, right? So the first thing here is that what's given to us, we are given with this function fx equal to x cubed plus ax squared plus 2x plus 9. I cannot draw, the graph is not given, the graph is unknown, I cannot draw the graph of this. So what could be the right way to know or to find the value of a? Okay, now I know this function fx is 1, 1 function. Okay, so what I can do here is that if this is 1, 1 function, then derivative of x, either it's going to be greater than 0 or it's going to be less than equal to 0. I hope you agree with me. Now, if you take the derivative, so f of x, what it's going to be? 3x squared plus 2ax plus 2. Right? So, okay, now this is the derivative. Now, this is the derivative. Then we have two conditions here. We have two cases. Now, this is my case 1 and this is my case 2. Okay. Case 1, 3x squared plus 2ax plus 2. It is going to be greater than 0. Okay. And here 3x squared plus 2ax plus 2 is going to be less than 0. Now, this is a quadratic equation, okay, quadratic equation, and here it's of the form ax squared plus bx plus c, and here a is positive. Now, this a is positive, right? It means that this whole quadratic equation, it's going to be greater than 0, okay, greater than equal to 0. Okay, now see here, if you don't understand this way, look here. Okay, this is the graph for this case, this is a graph for this case. Now a is greater than 0, okay, a is positive. It means that the end behavior, it's going to be rise up. Because this is quadratic, so we know we are going to get upward parabola. Why? Because a is positive. So here the graph would be upward parabola. Okay, so it could be like this, or it has to stay above the x-axis. Okay, now why I am saying that? Now, this case is not possible. Why? Because a is positive, so how can this quadratic can have the negative value? Why? Because if that's the case, then the graph would be the downward parabola, and this is only possible when your a is negative. Okay, so this is not possible. This is not possible. Now, this case is possible. Now, if this is possible, then see here, if this is possible, then what would happen? Okay, so if it is upward parabola, only two conditions will be possible, either like this or like this. Okay, or like this, or like this. Why I am saying this? Now, the third condition that you may think would be this. Now, see here, this is not possible. Okay, this is not possible. Why? Because if you are going to get the real roots, then you can see here your y is going to be negative. So this has to be greater than equal to 0. So only when it has equal roots, or if it has imaginary roots, okay. So when you have real roots here, then what would happen? Then the value, okay, the value of this quadratic, it's going to be less than 0. Look here, in this interval it's less than, but only this is going to be possible. This is not possible in this case, so we are not going to accept it. Okay, so only two possibilities are left. Okay, now for this thing to happen, so for this thing to happen, here I can erase this. For this thing to happen, okay, so this is only possible. Okay, now what does it mean? Your quadratic equation value is going to be greater than equal to 0 only when your d, it is less than equal to 0, right? I hope you understand now. Okay, this is the theory of quadratic. Why? Because d is less than 0 when you will get the imaginary roots. D is equal to 0 when you have real roots. So we just discussed two cases. Okay, when if d is greater than 0, it means you are going to have real roots. So that is not going to be possible. Okay, so your d, it's going to be b square minus 4ac. It's going to be less than 0, right? So from here, what can we conclude? Now, what's b here? So it's going to be 4a square minus 4a. What is a? 3. And what is c? 2, less than equal to 0. So from here, 4a square minus 24 less than equal to 0. Okay, so from here, 4a square less than equal to 24 and a square it's going to be less than equal to 6. B square, it is 4 a square, b square minus 4ac. 4a is 3c 2, right? 24 a. All right, so is that right? 3x square plus 2ax plus 2. B square minus 4a square minus 4 b square minus 4ac. 4, 3, 12, 12 to 24. Yeah, that's right. A square. Now, a square, can I write it like this? A square minus 6 less than equal to 0. And from here, can I write a square minus root 3 square less than equal to 0? So from here, can I write a minus root 3? A plus root 3 is less than equal to 0. So from here, can I say my a, it would be root 3 to positive root 3, right? So your a is going to be in the interval, right? So this is how you have to do when the graph is unknown or graph is not given, then you can rely on the derivative. Okay, so just find the derivative, and we know that it has to be less than equal to 0 or greater than equal to 0. So we did the same thing here, and then we figured out how to we figured out the theory of quadratic. Uh, this is only possible when your discriminant is less than equal to 0. You also know what does it mean. It means when you have imaginary and equal roots, okay, then the upward parabola case will be possible. Okay, so b square minus 4ac, we just did the calculations, and here we got this result. Okay, also, one more thing that I want to discuss here is that our 1 functions, this is important, 1 functions are known as injective functions. Okay, just keep in mind it's a terminology. Okay, so 1 functions are also known as injective functions. Okay, next time we are going to have a session on onto and into function. Okay, so have a great time, keep safe, bye bye.